Good morning, guys. Welcome back. So today for today's lesson, we're gonna be doing an overview from sections 11.1 to 11.4. So what I have here is a tab open just to show you guys the work that I'd be doing. I wanted you guys to be able to see what I'm doing when I'm solving for these problems. So again, I'm gonna go ahead and do this. And if this is through through Google Keeps. So if you guys have this, you can go ahead and feel free to use this as well. Um, and then what we're going to be doing, we're going to be actually going on to Quizlet. There are two review guides that I have for you. So we have the circle vocabulary, and then we have the one that is finding the area of regular polygons flashcards. And so for both of these, these are just vocabulary flashcards. So it's just to kind of help you, review the vocabulary. I think the main issues that you might have for these sections are the vocabulary itself and just remembering the different terminology and the formulas that we are using for these sections. And then later on, we're going to go ahead and play a game on Kahoot, but that's for the second part of the video. So for this part, I'm just going to go ahead and go over these reviews. This is the circle vocabulary, and so I would go ahead and send this to you, and then we're going to just go ahead and practice these. So we're going to have it on full screen. Let's see. If it lets me. Okay, let's see.
Circle.
Okay, so
the
circle.
set of all points on a plane that is set distance from a given point in the plane.
Okay.
An arc whose length is less than half of the circle, named with 2 points.
This is the minor arc. Okay.
An arc whose length is less than half of the circle, named with 2 points. Minor arcade.
Okay, so I'm actually going to switch it back. You can play around with it. I would recommend that you guys have it to the actual vocabulary word itself. That way you're able to really test your abilities to remember these. I'm actually going to mute that.
Major arcade. Major arcade.
I don't like that one. Okay, anyway, so we have the major arc.
Chord. A line segment whose endpoints are on the circle.
Let's do
a line segment whose endpoints are on the circle. Chord.
Okay, we move on.
A chord that contains the center of the circle. It is the longest chord of the circle.
Okay, this is the diameter.
A chord that contains the center of the circle. It is a line that intersects the circle in 2 points. It contains a chord.
That is the secant line.
Secant. Tangent.
Okay, the tangent touches the circle at exactly 1 point.
A line that intersects the circle at a single point. It is always perpendicular to the radius.
Okay, do note that it's always perpendicular. That's something that you guys have to make sure that you remember that one. Okay.
Point of tangency. The point where the tangent line intersects the circle.
Okay, so that would be exactly at this point. This is a point of tangency.
Central angle. An angle whose vertex is the center of a circle and whose sides contain radii of the circle.
Okay, very important. Again, this is always the so I like to remember it as the central angle if it's center. So central angle has the vertex at the center, and then obviously the sides are formed by the radii.
Inscribed angle.
Okay, this is different from the inscribed angle. These are
an angle whose vertex lies on the circle.
Okay, an angle whose vertex lies on the circle, so it's kind of like Pac-Man almost. Like you can see that the vertex is on the circle itself and not on the center like the other one.
Congruent circles.
Okay.
2 circles with congruent radii.
Okay, that's another important we didn't really go over the proof, but it was something that I mentioned earlier in the section, I want to say 11.1. Again, two circles are congruent only if they have congruent radii.
Concentric circles. Coplanar circles that have the same center.
Okay, so you can think of it as the target symbol, or just the target, right? That's pretty much what it is. They obviously don't have congruent radii, because this here radius is obviously smaller than the radius for the second circle, which is smaller than the larger circle. But they are like rings of a planet almost, right? You can think of it like that.
Tangent circles. Two coplanar circles that intersect at exactly one point.
Okay.
Tangent circles. Common tangent. A line that is tangent to two circles. Exterior of the circle. The set of all points outside the circle.
Okay, that one's pretty simple. It's just everything. We know what exterior means. Everything that lies outside of that circle.
Interior of the circle.
The interior of the circle is everything inside of that circle.
The set of all points inside the circle. Semicircle.
Okay, half a circle is
an arc of a circle whose endpoints lie on a diameter.
Okay, and then just an FYI that you know, if a full circle is 360 degrees, then half a circle or a semicircle is equal to 180 degrees. Just something that, I wanted to add in there.
Formula for inscribed angle.
Okay.
N less than x equals n.
So yes, so the formula for this one, again, the measurement of angle ADB, this angle here is half of the measurement of the entire arc here, AB.
Formula for inscribed angle with two lines that intersect inside a circle. N less than 1 equals.
So for this angle, it could be this one or this one. The angle would be a half of the sum of these two.
Formula for inscribed angle with two lines that intersect outside a circle. N less than 2 equals.
Okay, for this one, when the line or the secant is outside of the circle, then it's the difference of these two. Okay.
Formula for inscribed angle with two lines that intersect outside a circle.
And that is pretty much it, guys. The really cool thing about this is you can play it over and over again here. If you want to shuffle or make sure that you're really understanding it and not just memorizing the words, you can click here. And that's the really neat thing about this. Again, you can kind of go at your own pace and just keep playing around with that. So that was the first part. Now we're going to go ahead and go over the area of the regular polygons. And so this one has a little bit of definitions. Actually, most of them are definitions. Yeah, they're all definitions. Once we get to Kahoot, then that's where we're going to go ahead and be doing more hands-on with the problems themselves. So this one, let's see. So we have the definition of a regular polygon.
All sides are, all angles are.
Congruent. So all sides are congruent and all angles are congruent. That is what a regular polygon is.
Any regular polygon can be inscribed in a.
Any regular polygon can be inscribed in a circle.
Circle.
Mm-hmm.
Central angle of a regular polygon.
Okay.
An angle formed by two radii drawn to consecutive vertices.
So it's the same thing. It's just a central angle, except now it's being more specific to a regular polygon. But we obviously know that from the previous chapter or section. I'm sorry. N is in the
number of sides. Measure of the central angle.
Okay, measure of the central angle.
360 divided by n.
And again, when you want to find this, so if you have an octagon and you want to find the central angle, 360 divided by 8.
Radius of a regular polygon is the distance from the center to each of the polygon.
Okay, so radius of a regular polygon is the distance from the center to each vertex. Okay.
Radius of a regular polygon, P, is the center of the circle and the regular polygon.
Okay, in this case, I wanted to make sure that the P is just, this one doesn't really matter. It can be any variable, any letter. It's just how you define the circle. So it doesn't have to be P in this case. Actually, in your textbook, they usually note P as the perimeter.
S.
Okay, S.
Side of the regular polygon.
Okay, S is the side of the regular polygon. So here in this case, the entire thing is the side. Here is, we have the apothem, radius, and then everything else. Okay. Apothem.
The perpendicular distance from the center to a side of the regular polygon, the height of that triangle.
Okay, so that's another important thing. In the textbook, they have different ways of describing the apothem, but in here, I really like how they have it described. Again, it's the height of one of the triangles that is set up here. So this is very important. This is the height. This is the apothem.
R. Radius side of the triangle.
Okay, R is the radius.
P.
Okay, we're gonna just note that P should be the capital P.
Perimeter of polygon.
That's the perimeter of the polygon.
Perimeter of regular polygons. P equals S times N.
Oh, or you can just go ahead and, add up all the sides, however you like.
Area formula for regular polygons. A equals 1/2 AB.
1/2 A times P times the larger P, or in the textbook again, they have the area is equal to 1/2 the apothem times N times S. That's another way to solve for this.
30-60-90 triangle rules.
Okay.
Hypotenuse equals 2 times shorter leg, longer leg equals shorter leg times 3.
And this is obviously going to be coming back as we saw in chapter 11.3. We did start to notice that we are going to be using these rules. So make sure you are still remembering these. They're very important. Make sure you have these down again, okay?
45-45-90 triangle rules.
45
Legs or
by 90.
hypotenuse equals leg times 2.
Okay. And that is it, guys. So that's the last one. This one has 50 terms. The other one had 20. So it's not too bad. So now we're finally going to move on to the Kahoot. And this is the one where we have 11 questions. And we are going to go ahead and solve for some of these. So again, you're going to go ahead and do this either on your computer or your phone. So I'm going to go ahead and join right now. Okay. And these are all just reviews from 11.1 to 11.4. Okay, we are ready. Okay, so if the diameter of the circle is 10, then what's the radius? Okay, well, 10 divided by 2 is 5. If the radius of a circle is 5 centimeters, then what's the circumference? So I'm going to go ahead and go on here. So the circumference is equal to 2 pi r. So 2 times 5 is 10, 10 times pi, about 31. Okay, I'm actually going to take out my calculator really quickly just so I have it here as well, so you can see what I'm doing. Okay, then we move on to the next one. If the diameter of a circle is 7, then what's the circumference? So here it is the diameter, or this is the circumference is also the same as pi d. So I'm going to go ahead and do that. So 7 times 3.14, about 21.99. It doesn't give me too much time to show you guys, but just so you guys have an idea of what I'm doing and know exactly what I'm doing. So if the circumference of a circle is 12, then what is the radius? So the circumference is 12. What is the radius? So in this case, we have 12 here equals the 2 pi r, and then I'd go ahead and divide both sides by 2 pi. Okay, so I know I'm going to divide both sides by 2 here, and then I get 6 equals pi r. It's really hard to show you guys. Okay, and this is 3.14, so divide that 6 by 3.14. 1.91. There you go. Okay, before I continue, let's see, I'm going to keep scrolling down a little bit. Okay, find the length of the red arc. So this portion here. So let's see. So this was actually, I want to make sure that I'm on the right section for this one. Let's see. This one was all 11 point. This was all 11.1. This seems like a while back. Okay, so I'm going to go ahead for the arc. It is the measurement of this portion. So it is 40 over 360. Oh my gosh, 40 over 360 times 2 pi r. Times 5. I'm just going to go ahead and show you. Remember, this is again 11.1. It's the measurement of the arc over 360 times 2 pi r. And I ran out of time. So this actually looks like it's a quarter of that. This is, okay, so it's 90 degrees, and the radius is 12. So 90 over 360 times 2 pi r. 2 pi, and the radius is 12. So this is 1 over 4. This is 24 times 3.14. So let's do that. 24 times 3.14. That divided by 4 is 18.84. So it's right over here. I just rounded it off. Find the length. So find the length of the red arc. Okay, so it's the same thing. Oh, let's see, where is my 15 and 145? 145. Over 360. And then this is 30 times 3.14. Where's my calculator? Sorry, 30 times 3.14, and then that times 142 over Ooh, it did. Sorry, guys, it did not. I wasn't not able to get through this portion. Okay, let's see. Let's see if I have more success for the next one. So I'm just gonna go ahead and do it. Let's see. So it'd be 58 over 360. And then that times 2 pi r times 2 times 3.14 times my radius, 11.12, which is my triangle. Oh, I made a mistake there. Ooh, something happened there. Yeah, we're gonna have to just keep going for now. Find the length of the red arc. So in this case, of the red arc. So that means this is giving me the angle of this portion here. I actually want the rest of it. So 360 minus 120. That's this angle measure that I want to use. So it'd be 240 over 360. That times 2 pi r. So times 2 times pi times the radius, 92.1. So right over here. See, that was the thing that I messed up on the other problem. Sometimes they're going to be tricking you like that, and you'll think that the angle that they give you is the angle for that arc that you're looking for, but it's actually the opposite. So you want to make sure that you do subtract that from 360. Okay. Okay, so find the length of the red arc if the length of the diameter is 20. Okay, if the length of the diameter is 20, then I know that the radius is 10. And then the angle measure is 180. So I'm going to do 180 over 360 times 2 times pi times r is 10. Ooh, 31.42. There you go. And we are on our last problem. Find the circumference of the circle given the length of the red arc is 15. Okay, so look carefully that this measurement is in fact for this here. The circumference is okay, so the circumference is 2 pi r. Given the length of the red arc is 15. So I'm gonna actually have to go backwards. So the arc length is 15, so it'd be 15 over 15 times 360. I'm doing all of this backwards, so it'd be 15 times 360 divided by the measurement of angle of the arc here, which is 80. So divide that by 80. And that is equal to 2 pi r. So 67.5, which is my square. And there you go. That was a little tricky one. Let me just show you quickly what I did. They said the circumference of the circle given the length. Okay, so what I did for this, I'm still using this formula. However, instead of the arc length, so normally the length here is what I'm looking for. So that's what I was doing in these other examples before that. So what I had was the length equals to the measurement of the arc. So I'll just put measurement of arc AB for now. All over 360 times, we said it was 2 pi r. Well, we know 2 pi r is the circumference. So technically this is just C. So what I did, I multiplied both sides. I'm trying to isolate the C, so I multiplied both sides by 360, and then I divided both sides by the measurement of arc AB. That way I can get C by itself. So this is what I did. And then I divided by the measurement of arc arc AB. equals the circumference. And everything else I pretty much I filled it in here. This is a multiplication. Okay. Alright guys, so that was pretty much it for the game. Just keep playing the game, and then it shouldn't be too difficult at this point. I think the only thing that maybe would be a little bit harder to remember was definitely the arc length formulas that we did in the very beginning of chapter 11. But it's a really good review, and again, I think this is going to help you to keep in pace with everything that we've learned so far. So just keep reviewing, and then we'll see you guys for section 11.5. That one is actually going to be the volumes of prisms and cylinders. All right, bye guys, have a good one.